To be able to add these, you need common denominators. And right now I have x minus 2 and x minus 1, and neither can be factored, and they're not the same. So I need to rewrite this as 3x over x minus 2 plus 5 over x minus 1 with a little bit more space, because I'll multiply each of these fractions times 1. It'll be a very specific one. It'll be the parts of the denominator that are missing. So for this first rational expression, I'll multiply by x minus 1 over x minus 1 so that the denominator has both factors. And for the second one, I'll multiply by x minus 2 over x minus 2. So now we have common denominators. We'll distribute the polynomials and the numerators. So 3x I multiply times x and times -1, and 5 I multiply times x and times -2. But now when I do that and I start to combine these, I can write it as one fraction because the denominators match. Like this, 3x squared minus 3x plus 5x minus 10. And my denominator is x minus 1 times x minus 2. And you combine like terms. Combined, this is 3x squared plus 2x minus 10 over x minus 1 times x minus 2. And we'll still have excluded values, which would be anything that makes your expression undefined. All the x values that would make your denominator 0. The denominator would be 0 if x minus 1 is 0 and if x minus 2 is 0. So we exclude both of those values, which would be 1 and 2. How's that? Okay, let's do another one. So for my second example, I need to add these. I need to factor the denominators. I need to make sure the denominators match. I need to define my excluded values. I'll simplify and combine like terms. So first, with this one, my denominator on the right side can be factored. This is 2 times x plus 1. That's useful because then I can reduce this fraction. 4x is 2 times 2 times x, and my denominator here is 2 times x plus 1. So before I make common denominators, I can reduce this because there's a 1 right here. So when I go to make common denominators, I will write this so there's more space. And my second expression will be reduced. So now So now I don't have to multiply the other one times 2 because that was simplified to a 1. So now when I multiply by what's missing, I have x plus 1 over x plus 1 for the first expression, and x plus 3 over x plus 3 for the second expression. And I distribute the numerators. Oh, I don't know if you guys caught it. I changed this minus to a plus. Be careful. Make sure you don't make a sign error. Also, it's sometimes a good practice to just write the negative with the number so that you make sure when you distribute that you don't make a sign error. We'll have to change this to a positive, and I'll put the negative with the 2x so that then when I distribute, I'll distribute negative 2x, and I can make sure that I get that negative from the subtraction. I'll also distribute the 4 into this first group. So for this problem, I have 4x plus 4 minus 2x squared minus 6x divided by x plus 1 times x plus 3. And I can combine like terms in the numerator. There are 2 x terms, so I can rewrite this as negative 2x squared minus 2x plus 4 over x plus 1 times x plus 3. The excluded values for this simplified expression are -1 and -3.